Hello, one and all. So the topic that we have chosen for the given theme, AI for sanitation management and rural development, is water quality monitor. And the challenge that we face in rural communities is due to limited infrastructures and resources. The water sources tend to get infected by various bacteria and pathogens, etc. And our solution is to, with the help of this water monitor, we are going to identify whether the water is suitable or unsuitable for drinking and other domestic purposes.
So before finding solutions for the water problems caused in rural areas, first we have to know the cause for these water problems and water pollution that is caused in the rural areas. So mainly water pollution is of two types. We know it's as of natural causes and it's of man-made causes. And some are, to state a few examples, it's due to the discharge of toxic chemical waste from the factories into our bodies, and disposing of garbage and etc. As I said already, there are two causes. One is the natural causes, which is caused by animal waste, algae, and silt depositions from floods, and the other is the man-made causes that is created by us humans due to sewage water discharging directly into the river and the local water bodies, and use of chemical fertilizers and so on. So now we'll see how does water get dirty. Again, we humans play a very major role in making water polluted and very contaminated. And this is very prevalent in the rural areas, as there are many rural activities that involve washing animals or washing utensils, washing clothes in the river bodies, and these lead to the cause of more growth in pathogens. And also factories allow water to flow through the local river bodies that are present in the rural areas. And due to this water pollution, there is death of aquatic animals, but also this disrupts the food chain entirely. And not only that, it also causes a huge hindrance for us human beings, as the water that we use for our domestic purposes is also getting contaminated by the pathogens and other effluents that are created, which leads eventually to disease, which is more prevalent and more seen in the rural area. And so this is how our interface is going to look like. As you can see, here are the parameters displayed. Here are the parameters displayed. As you can see, there are parameters such as the pH value of water, turbidity value, dissolved oxygen value, TDS value, and so on. These values are all received from our sensor that we have placed, and it is fed back into the software. And here the pH value is 7.2, which is suitable for drinking, and so does the turbidity value, which ranges from 10 NTU to 100 NTU. As it is 10 NTU, it is also fit for drinking, and so on. The dissolved oxygen level is for the tested sampled water is 8.5, and the TDS value. After all these values are being fed into the software using the help of AI determines whether the water is usable or not. Here it shows that the treatment recommendation, whether the water is usable or whether the water is not usable, and that's how the interface works, and that's how we are finding it. So here's just an entire overview of how the water quality check is going to take place. First, the water sample is taken, and next the data from the sensors such as pH sensor, turbidity level sensor is processed, and the processed data is sent into Arduino, from which algorithms for the AI tool to be used is encoded into it. And after considering all these values from the sensors, addition is made whether the water is suitable for drinking or whether the water is unfit for drinking, and finally the output is shown as whether the water is fit for drinking or unfit for drinking.
So the sensors that are going to be used for the water quality monitoring are the pH sensor, turbidity sensor, conductivity sensor, and dissolved oxygen sensors. These sensors are all essential to monitor the water quality, such as the pH sensor for whether the water is alkaline or acidic, and turbidity for the level of cloudiness of turbidity of water due to the suspended particles and etc. So the pH sensor and all these sensors are going to be integrated with Arduino, from which instructions and code is going to be written such that the AI is going to carry out all of this process, and in the end result, it's going to say whether the water is usable or not usable for domestic and personal consumption. At first, the pH sensor is integrated with Arduino. The output is going to be an analog voltage signal proportional to the pH level. The data will be stored in the Arduino board. And for the turbidity sensor, it's going to be a digital signal which is going to be integrated with the Arduino board. The Arduino software will interpret the signal and will map it into turbidity levels using the calibration data. Further, conductivity sensors also will be providing an analog voltage signal, which is going to be proportional to the conductivity of water, and the Arduino software will interpret the signal and convert it into conductivity values using the calibration data that is provided. And finally, dissolved oxygen sensor will also provide an analog voltage signal, and using calibration values, the data is going to be stored in the Arduino software. By using this Arduino software, later the codes are going to be written for the AI tool to say whether the water sample is fit for drinking or domestic purposes, or is it not fit for drinking or domestic purposes.
Okay, thank you.